Okay, welcome to Class TV. I myself Aliwi Tosin. Now, we are taking part three of our topic equilibrium of forces. Now, here we are talking about conditions for equilibrium of rigid bodies under the action of what? Parallel forces. Under the action of parallel what? Forces. Now, under the action of parallel forces, there are some conditions that has to be what? To be to be intact before you can say that what a body is what is said to be under to be what it be equilibrium. Now, conditions for equilibrium of rigid bodies when it is what under the action of parallel forces. One, total upward force is equal to total what downward force. The total upward force is equal to what must equal to total downward force. This telling us that the total forces in one direction are equal to the total forces in other what direction. Secondly, the algebraic sum of moments of all forces about any point should be what? Should be zero. The algebraic sum of moments must be what? Zero. What are we saying there? It means we are saying that what? The total clockwise moment of the forces about any point is equal to the total anticlockwise moment of the remaining forces about the same point. So what you are saying there, you are saying that what our if this F1 and plus what F2 must equal to what? Zero. Note our F1 if it is the clockwise moment, if it is clockwise force, then our clockwise is what is the negative, while the anticlockwise is what is positive. So when you add it together, you see that you end up having what? You end up having zero. When it is zero, then it is what? At equilibrium. It's at equilibrium. Now the total resultant force must also be what? Zero. Total resultant force must also be what? Zero. We told you that the resultant force is the force that is having the same effect as the what? The two other forces. So we explained that in the previous class. So one, the resultant must be what? Zero. Two, the sum of the algebraic sum of the moments must be equal to what? Moment of all forces must be equal to zero. And again, the upward force and the downward force must be what? Equal. These are the conditions for equilibrium of rigid bodies under the action of what? Of parallel forces. Now, under the action of non-parallel forces, two things are important. The line of action of the forces, right, must meet at a point. Yes, that means it must meet at what? At a point. It means it must be concurrent. So it means it must meet at a point. And again, the resultant force should be zero. Yes, the resultant force must be what? Must be zero. Okay, that was not written here. The same thing applies here. We are still having it here. And again, the algebraic sum of resolved components of the forces in any perpendicular direction is what? Respectively zero. Algebraic sum in any particular direction is what? Zero. We said the total resultant force must be what? Zero. And the line of action of the force must also must meet at a point. It must meet what? At a point. That is for non-parallel forces. Now let's note this. For three non-parallel coplanar forces, if you have this as the F1, and we have this as F2, and this as what? F3. Now, for these three non-parallel forces to be what? To be at equilibrium. Now, these conditions also has to be what? To be ascertained. First, for this to be executed, the resultant of the two forces must be equal and opposite to the third. Resultant of this force 1, 2 must be equal and opposite to this what? Third. Before you can say that it is what? It is an equilibrium. Is that what? The three forces are what? Equilibrium. If this is not equal to what? If these two equal one are not equal to this, then we say that what? they are not what on equilibrium. The second one is what? It said the lines of action of the forces must meet at a point. The lines of action of the forces must meet at a what? At a point. All the three forces must be concurrent. That means they must what? Meet at a point. Yes. Said they must meet at a point. The three forces must meet at a what? Point. The line of action of the third forces must pass through the point of intersection of the line of action of the other two forces. Now these are the other two forces. The line of action, this line of action must pass through the what? The point of intersection of these two forces. The line of action of the third must pass through the what? Point of intersection of the what? The other two forces. And still the algebraic sum of the forces at a point must be equal to 0. The algebraic sum, that means you find algebraic sum of, that is summation of f must be equal to what? 0. 0 is 0. We are saying that what? Our f1 plus f2 plus f3 must be equal to what? 0. The algebraic sum must be equal to 0. And the forces can be represented in magnitude and direction by the size of what? A triangle taken in order. The forces can be what? Represented by this size of a triangle taken in what? In order. Where this f1, this f2, and this what? f3. This was f3. Okay, so that is what, as far as that is concerned. So those are the conditions for equilibrium of rigid bodies under the action of parallel forces, under the action of non-parallel forces, and also conditions for equilibrium of three non-parallel coplanar forces. These three non-parallel what? Coplanar forces. Non-parallel coplanar forces. So that brings us to the end of this topic on this segment. We'll continue in our next class where we talk about the concept of what? Center of gravity. I read myself Aliwi Tosin. Thank you.